for the lower, the reason why I bumped that one back to 28 minutes is because it's only a 90-second or 1.5 minute cycle. That cycle will be over when this one kicks in right on the even 1/2 hour, which I set it at. So we want our frequency for this lower one to equal 30 minutes, or right on the 1/2 hour. So it's going to do 2 times exactly every hour. So this lower irrigation, you'll see it kick on right after the upper, or whatever. What was the upper irrigation? 28 minutes for 90 seconds. So 30 seconds after that upper irrigation shuts off, you'll see this lower irrigation kick on. And you'll be able to hear the solenoid click open. There's a flow meter that shows you gallons per minute directly above the solenoid. And you'll be able to see the flow. There's a pressure gauge above each, the upper and lower irrigation lines. So right there, you'll be able to see what's on, what's off, the flow that you're getting in gallons per minute, and the PSI that you're getting through your line to your systems. So this will go on every 30 minutes. So we have to do that one half thing with the multiplier again. So for a frequency, again, we always set it to C. Here again, we're going to set our range from 0 to 3. We're going to set our multiplier at 10 minutes. And once again, we have to set this for 1/2. So 1/2 of 30 is 15. What times 10 equals 15? We're going to go .5. So that's going to get set right at 1.5. So 1.5 times 10 gives you your 10 minutes, gives you your 15 minutes. That's 1/2 of your frequency, your desired frequency, 30 minutes. So that's going to be the setting for this one. The design duration time for this lower irrigation is 66 seconds. So every 30 minutes, your lower irrigation is going to kick on for 66 seconds. And this is kind of the straight shot function here. So this mode is always going to be on A for your duration timer. Your range is going to be 0 to 18 again. Your multiplier is going to be 10 seconds. So we have our little windows. I'm going to show 0 to 18. We're going to have our little timer here. And that's going to be set at 6.6. So 6.6 times 10 seconds gives you your 66-second duration time. As time goes on with this, initially these won't overlap. For maybe 1 or 2 cycles, they may overlap slightly. You'll see a drop in pressure. That's no concern. As time moves on, they'll separate again, and they'll function independently of each other. So that's not something you have to be concerned with. The humidification chamber that we talked about earlier, which is the pre-humidification chamber, that the water comes through these nozzles initially to humidify the air, that's going to be running constantly. So as long as the air is getting blown into the system, that humidification chamber spray system has to be on. And that, I believe they are going to add a frequency and duration function to the SCADA system, and I think you'll be going through a separate SCADA training. And that frequency and duration is set using a similar flow meter that you're going to see for the upper and lower irrigation systems that's on the blowdown line in the closet that reintroduces that fresh water into the humidification tank. You'll be able to see your gallons per minute flow that you're getting into that tank that's available to you. You can take that gallons per minute, and there's a certain percentage of new water that I've designed to get reintroduced to this humidification sump twice daily initially. That may change going forward if you see your pH drop below 4. But for right now, those timer settings have been all worked out and will be entered into the SCADA system.
Are there pH probes in the sumps?
Not that I'm aware of.
So they have to be checked by hand, the pH?
I couldn't go forward at this point to tell you what method is gonna be used. That's kind of out of my scope for this. But that is something that I'm sure will be, you know, different testing procedures and things like that, that you are gonna be coming in contact with, you know, media or water. I'm sure those will be outlined to you at some point. We do have initial performance testing that we will be doing that is yet to be scheduled. That will probably commence as the acclimation period to this filter, you know, brings it up to speed.
When you want to continuously monitor the pH in the sump to make sure you don't go too low,
You're not going to get that initially.
but once the system is up and running,
Sure, you're going to want to monitor it probably, you know, every few days or so to see what kind of pH you're getting, and then you can adjust on the SCADA system the frequency and duration that you reintroduce new water to your system until you get your desired pH of 4.
Have you seen at any point, have you had any problems with temperature changes as far as your settings for your frequency and duration timers?
Those are pretty much going to stay standard. So you'll never really have to change those unless the characteristics of your airstream change. There is a temperature probe that is hooked up to the SCADA system, and there is also little temperature meters on the pipes coming from the heat exchanger. So you can monitor your water temperature from inside the control cabinet, and you can also monitor your air plenum, that void space underneath the media, underneath the grating. That temperature can be monitored through the SCADA system. So say it dropped to 0 degrees here, and all of a sudden your SCADA temperature registered 45 degrees. And you're like, well, wait a minute, 55 degrees is the cutoff. We're going to have a microorganism starting to go dormant. Well, what you could do is that there's a temperature control for that glycol, and you could bump that up until you see the desired, you know, temperature change, bring you back up above that critical level in your air plenum for your filter. One thing that happens with this biological reaction, though, is that as this occurs in the system, it will naturally create heat in your media bed too. So it will be self-heating to some extent. So you know, with just some minor adjustment, you know, if it gets extremely cold in your SCADA system to the glycol loop, should introduce warm enough water to that system to keep that media bed above that desired temperature.
well, the fiberglass pipe going to the plant is uninsulated, so if it gets really cold outside, that pipe, those gases are gonna get cold.
The gas.
Airflow.
Oh, yeah.
You have to go, you don't want, I mean, I don't know how fast the velocity is on that pipe, but there's no insulation on it, so it's gonna cool off real quick.
Mm-hmm. Well, this specific design, this specific biofilter was designed for a design airflow temperature. So the plant or others involved will have to take some further steps if it drops down real low.
Shut it off.
And there's also procedures for that. If you ever have to shut the system off, if anything happens, depending upon the length of time you shut it off for and how cold you let the system get, you might lose populations of certain bugs. Some might go dormant. So when you fire it back up again, you might not see a removal efficiency in the 99th percentile until you regrow your biological organism population.
Now, will the mass ever get to the point where you have to slough it off somehow?
The what?
The mass inside your filter, will it ever get to the point where you have to slough it off? Clean out your filter, will it plug the orifices?
Squirt hole, that's probably
In the
what they're
media?
thinking about,
Yeah.
especially this one right here, 'cause it's kind of a dripping filter.
No. typically, no, you won't see that. You won't see a lot of like algae growth or anything like that. You shouldn't in your system. As you know, the media deteriorates over the course of its life, your media bed is going to become more and more compacted eventually, and you can measure that in like the inches of water pressure that you're seeing in your inlet airflow stream. And when that gets above, I think, in around 10 inches of water, that will kind of signify to you that either you're having a problem, some other problem within your bed that would have to be evaluated at that point in time, or you're moving towards the end of your media life. If you were to measure your pressure drop, it might not even register right now. It might not even go above 1. But you could measure that, you know, in whatever time increments you'd like to measure it in. And, you know, eventually over 5-10 years, you'll see that pressure drop increase. When it hits around 10, that's kind of when it's, if it does that real soon, you've got some other problem. And then we'll have to figure that out. But otherwise, you shouldn't see numbers like that for a long time.
Now, on the exhaust end of this filter, that sulfuric acid, is that a concern for operators? I mean, is it going to be strong enough where it could burn your skin?
No. You have the sulfuric acid is in the water, and by the time your airflow reaches the top of your media bed, it's going to be pretty well filtered. So you won't have sulfuric acid coming out the stack. If anything, it would just have some hydrogen sulfide in it. But I don't think that would be the case. As far as workers and safety is concerned, their main concern probably with contact with the sulfuric acid is if, you know, any maintenance has to be done down in, well, the only accessible area is the prehumidification chamber. So if they're down in the bottom of that, there might be some sulfuric acid in and around that area that's draining out of the media bed there. We have those open air plenums. Or they may encounter it, you know, if they have to do anything with the drains. The
How about
drains
pull
would
the
be,
pump?
excuse me?
How about if they pull a pump?
When they pull a pump, yes, all the necessary safety and all of those guidelines and the safety gear, you know, they have to be adhered to. I mean, there's an outline in there, but I think there's, you know, many standard practices out there for dealing with water with low pHs and things along those lines. If they're pulling those pumps to repair a pump, like I said, that water that's that new water that's getting reintroduced should be adjusted to maintain a pH of 4. So going forward with whatever pH you may have in that sump at that point in time, if you're doing any maintenance, you're gonna have to take the necessary precautions.
Just add more water.
That's how you'd add the
Dilute it out for the maintenance.
Yep.
Because that would not be a concentrated sulfuric acid either, right?
Well, that water is recirculated, so you're gonna get some in there, but that's the reason for introducing that fresh water.
Right.
So there is gonna be a dilute solution of it in there. If any maintenance has to be performed on that sump, I would fill the whole thing up with fresh water, let it drain to the waste sump, and you know, maybe check your pH then again too, just to be safe. Those specific procedures would have to be gone over at that time.
Question, confirm it's neutral or safe. Now, you're gonna be feeding a nutrient that's gonna have a buffering capacity as well, right?
There is a dosatron, and what this unit is that as water in the pipe passes through this dosing unit, depending upon the flow in your pipe, it sucks up a certain ratio of nutrient. And this nutrient is just a liquid fertilized nutrient that you put in your nutrient tank. I believe it's probably a couple times a month, you'll have to fill up this nutrient tank with water, and I'll go through that with you out there. You have to fill up this nutrient tank with water, dump 2 gallons of this liquid nutrient in there. And what that does is that this dosatron sucks up this nutrient out of the tank through a hose and injects it into the water stream. And it goes through the pipe up and it sprays out in your upper irrigation system. And what that does is that it just provides the microorganisms with a constant flow of nutrients and keeps them working at a very, very high level. So that's one thing too, as far as operation and maintenance is concerned, that you're going to want to pay attention to initially is that level in your nutrient tank. When it gets to be about 6 inches towards the bottom, you can see a little screen, a little hose at the bottom. Once that's not exposed to water, if it goes dry, there is a fill hose and valve right next to the tank. You just open it up, fill the tank to the top. You should have a couple gallons of this nutrient, dump it right in, and you're good to go. And that stuff will not burn you. If it comes in contact with you, don't ingest it. Very common. It's very common sense.
Don't drink it, Jim.
Common sense. The ratio setting on that dosatron is like 1 part per 500 with the flow coming through that pipe. So, it's not going to be a weekly thing. We'll just go over kind of the piping and how the flow goes, and then I'll show you everything in the cabinet, and probably some of it is going to be a little bit of repetition, and then we'll flip it on. I have the timer set where you can actually see them go on and off, and then a couple people at a time, maybe we'll step up over on top of the humidification chamber. You can take a peek down in the humidification chamber. You can see the pre-humidification chamber working in the spray nozzles. And then you'll also be able to take a peek inside the biofilter and see the upper irrigation sprays too. So I'll head over here. Okay. All right. Well, coming from behind this, this is kind of hard to see, but yeah, this is the nutrient tank. So coming from behind this tank, you see your main water feed coming in this copper piping. It's going through this filter. This is the 120 mesh filter that protects the system from the suspended solids, when the plant water starts being used. This is removable, and there's a basket in there that can be cleaned and taken out. The water then all right, and there's like an automatic, it's like an automatic type of there's like a blowdown function on this filter. This pipe right here just goes to the floor and then goes to drain here. After it's filtered, you can see it goes into the main feed line of the irrigation system. You have your pressure reducing valve there that's set at 50 psi. You have a pressure gauge there where you can monitor if you're getting any spikes in pressure. If for whatever reason you see that go above 50 psi,
like it is now. Like
that's static. Once you open it up, the pressure reduces greatly. You can adjust it then. The water then comes up here. And we'll do the upper and lower irrigation systems first. So we'll follow this line. It goes up into this 50 micron filter. This filter, its sole purpose is to protect the dosing unit that I spoke about, which is that dosatron, that blue unit right there. It protects that from fouling and clogging. So the water goes through.
How long did our filters usually last?
Excuse me?
Yeah, change our filters too?
This is potable water, so this filter, you shouldn't see a lot of clogging in this filter, but once a month maybe I definitely check this filter and clean it out a little bit if it's necessary. In order to do that, there's just this little plastic filter wrench here. You can just put over the body, and it screws off. If you ever do maintenance on this filter or cleaning, When you take it off, there's like a little rubber ring seal on there. You want to make sure when you screw that back up that it seats evenly in there. Otherwise, you will see some leaking come out of this. Anytime you do any maintenance where you're opening up lines, you might get some air in the lines. There's this red bleeder button on top here. You can bleed the filter. Same goes with the dosatron unit. If there's ever air gets in the hose, if the tank runs dry and there's air in the hose, there's a little black button on top of that dosatron unit where you can hold that down and it'll bleed the air out of your dosing unit there. So as we move on in this piping run, I'll just step right here. At first, this is the upper irrigation solenoid. This is one of the solenoid valves that's operated off a timer in this control panel here. When that timer opens this valve, you'll be able to see the flow that you're getting through your line with this rotometer here, and also the pressure through your line with this pressure gauge. It goes up, around, back down. This dosatron unit here is set to the 1:500 ratio that I spoke about earlier. It will inject nutrient, pull nutrient up from this tank through the hose and inject it into this pipeline. It will then follow out this wall into your upper irrigation pop-up spray nozzles, those black pop-up nozzles that I passed around during the classroom presentation. Coming back down here, you can see it splits off, goes up into this solenoid, which is the lower irrigation solenoid. That's also operated on its own set of frequency and duration timers in the control panel. When that opens, again, you'll see the flow through your rotometer here. As of right now, I think the flow that we have is a constant flow. If it needs to be adjusted, I believe it could probably be adjusted outside of this cabinet, somewhere down the line where the water supply is. And then it follows it up around. It doesn't require a dosing unit. That's only for the upper irrigation system. And then follows out through this wall here and goes into the pressure compensated drip hose in the humidification layer of the bed, that brown hosing. And that's where that goes. We'll back up a little bit here. This pipe run here splits off and goes to, this is the line that operates your pre-humidification chamber nozzles. Those orange nozzles that I passed around, this is the line that feeds that. So you have a solenoid valve here that, and some other piping runs here where you can bypass the solenoid into this flow meter where you can monitor your flow rate, and again with that flow rate you can adjust the amount of times daily you have to blow down or reintroduce fresh water to your humidification chamber to reach your desirable pH in your recirculation sump, which we'll take a look at over here. Randy, if you'd like to take a step forward. Randy will explain just a quick explanation of this heat exchanger and how the water is flowing through this heat exchanger and where it's going.
The glycol comes in the building right here on this line. And this is all based on the desired temperature in the humidification chamber. It just comes in the building and it'll just make a quick recirc line and it'll leave the building. Right here, this valve is closed. When you need higher temps in the humidification chamber, this valve opens and flow stops going this way. It now goes into the heat exchanger and will come out of the heat exchanger and back out of the building. So just say your temperature is 60 degrees desired in that chamber. This valve is tied to a temperature probe down there, which sends a signal back to SCADA, and this valve will regulate on its own until it achieves that desired temp. So flow from the humidification chamber manhole comes in right here. You follow it The bypass is closed right now, so you're coming this way into the heat exchanger, achieving your temp, and I'm leaving the heat exchanger and I'm going into the chamber. So
And as I said before, the desired temperature of the media bed can be monitored in the SCADA system. If it were to get real cold and the temperature that we're seeing in our media bed drops significantly with cold temperatures, the temperature can be raised via the SCADA system in order to heat the water a little bit more in the irrigation and humidification system.
There isn't an automatic set point?
The automatic set point right now is 60 degrees.
Okay.
If that ever bottoms out, where it's reintroducing new glycol at a consistent rate, but not achieving the 55 degree cutoff, then you might have to increase then your set point.
But it's automatic. It should be automatic. It should monitor it